Good day, grade 10 science students. Today what we're learning about is ionic nomenclature. Okay, so that means naming ionic compounds in a particular manner, which we call a nomenclature, which means to name. We're actually using in this whole course using something called IUPAC, which I don't expect you to know. It might be a bonus if you do, but it stands for International Union of Pure and Applied Chemists. They're the ones that came up with this method of naming. Today what we're focusing on is naming ionic compounds with something called polyatomic ions. What's ionic? What is an ionic compound anyways? Well, it's a compound that's held together by positive and negative ion attraction. So you have what we call a cation being attracted to an anion. And overall the charge is neutral. So if you have a 2+ charge, you need a 2 negative charge. And the cation and the anion charges balance out. So what's a polyatomic ion? Well, poly means many and atomic means atoms. So there's some atoms out there, some ions out there that are actually not just made up of one type of atom. They're actually made up of multiple atoms. And they have a charge. They can either be a cation or an anion. So again, they're made up of more than one atom. That's what we're going to say. We're going to change that to made up of more than one atom. And they act as a single unit, ion. The ionic charge of a polyatomic ion is shared over the entire ion rather than just on one atom. So here's a list of some polyatomic ions, and these are going to be found on the back of your periodic table. I'll show you where to find them in a second. But this is an example, hydroxide, and it's an O and an H, two nonmetals, and they actually have a negative charge here. Okay, overall. This is bicarbonate. It has a -1 charge as well. This is something called nitrate. It has a negative charge as well. You notice how I write it? We call this superscript up and above. And then we have carbonate, which is 2 negative. Okay? So how many atoms are in this ion here? Well, the answer is there is 2 atoms in this ion. How many atoms are in this bicarbonate ion? Well, there's 1 hydrogen, there's 1 carbon, and there's 3 oxygens. So that's 5 atoms. 3 + 1 + 1, that's 5 atoms. And overall, what's the charge of that? -1. Jump down to carbonate. How many atoms are in this ion? Well, there's 1 carbon, 3 oxygens, and so that is 4 atoms and has a 2 negative charge. How do you know when it is a charge and when it's the number of atoms? Well, if it's written down below, it is a number of atoms. If it's written up above, which we call superscript, it's the charge. And that's important that you know that and don't make that mistake. So let's look at the periodic table to see where we can find these polyatomic ions. So here's a periodic table, and here's the nonmetals, here's the metals here. Okay, the polyatomic ions are going to be found not on the front side of the periodic table, they're going to be found on the back. So if you flip your periodic table over, you'll see a list of ions right here. There's a list, so if you want to highlight this, flip your periodic table over, take a look. These are the list of the polyatomic ions, and also at the bottom of the periodic table there's also a box here. So where are the 2 locations? Here and here. So let's see if we can use this chart to see if we can name polyatomic ions. Okay, so what we would do is we would look for the number of capital letters here. So first of all, I recognize sodium. I see that it is a metal. So as soon as I have a metal, I know that it's ionic. So then I see that I have more than 1 capital letter. I have an O and I have an H. So this immediately means I look at the polyatomic page for that O and an H. So if we look on the back of the periodic table, if we look for Na, it's in group 1, we would name it sodium. Okay? And then we look at OH, which is on the back, and we find it, and its name is hydroxide. And we're done. So the same thing here, we look at this name or this formula, we see that we have calcium, which is in group 2 on the periodic table. And then we notice we have more than one capital letter, so we have to look for CO3's name on the periodic table. And it's actually on the back, so we're looking on the back because it's more than one capital letter. Carbonate. So when you have more than one capital letter, you look on the back. Let me just change that a little bit. You can see that all these three things have three capital letters. Okay, so if you have three capital letters and one of them is a metal, which is on the left side of the periodic table, so you have a metal and you have three capital letters, you're going to take a look at the non-metals and on the back of the periodic table. And you're going to find the name and just write it down. Okay, so what if we have a name? So for example, what if we have a name of, let's go up here. Sorry, 1 second, it's not working right. So I have a name of something like calcium sulfate. Okay, so I have a name of calcium sulfate, and I want to get a formula. So I have to use the capital letters to represent how many atoms are present. Okay, so I know when we have to name this, most of the time, the first rule that I'd like you to write down, you can pause this and write this down. If it ends in 8, it's probably on the back of the periodic table. 8 or 8. So if it ends in 8 or 8, it's on the back of the PT. And the rules are the exact same as for a binary. You write the metal first and write its charge, and polyatomic and write its charge, and you crisscross. You don't write a 1 as a subscript. So let's just see if we can try this here. So what we do first is we look at our periodic table. We see calcium is Ca. It's in group 2, so therefore it has a 2+ charge. And then we have sulfate, which is SO4. Where would I find sulfate? I'm going to find that on the back of the periodic table. Now that whole thing has a 2 negative charge. This is 4. Remember, it's 1 sulfate is SO4. So we have 1 sulfate and we have 1 calcium right now. And if we cross the charges, this is what we would get. Ca2SO4, and I have to put this in brackets now because I have more than 1 sulfate. So whenever you have more than 1 polyatomic ion, you have to actually put it in brackets. Why? Well, if I wrote Ca2SO42, that sounds like I have 42 oxygens, okay, which is wrong. I have 2 sulfates, not 42 oxygens. So anytime you have more than 1 polyatomic ion, it has to be in brackets. We then have to reduce this to the lowest amount to be neutral. Okay, so it's going to be CaSO4, and I'm going to get rid of that bracket now because I just have 1 sulfate. Okay, we're going to do a simpler one because that was a little bit difficult, but at the end of the day, we have 1 calcium ion represented by this circle with a 2+, and we have 1 sulfate ion with a 2 negative, and it's neutral. Okay, the positive charge equals the negative charge. We've reduced it to the lowest terms. That's what that means at this point. Okay, so we're going to write a few examples here. We have simpler examples for you now. Sodium hydroxide. Look on the periodic table. Sodium is in group 1, so I put a positive 1 charge. Hydroxide, I recognize that as a polyatomic ion, even though it doesn't end in 8. It's the only example like that. It's OH negative. I have 2 ions right now, a sodium and a hydroxide. The formula is NaOH. It's 1+ and 1 negative. Okay, it matches up perfectly. The next one we have is potassium carbonate. Potassium has a positive 1 charge, and carbonate has a 2 negative charge. Okay, so when you cross over your charges, what you're going to end up getting is K2CO3. The 1 goes down here. It's not 31 though. You have 1 carbonate, and you bring down the 2 here, and it's K2CO3. So this means we need 2 positive 1 potassiums to match up with 1 carbonate, 2 negative. So this whole thing here is acting as the 2 negative. Finally, we have magnesium nitrate. Magnesium is a group 2 ion, so it's got a 2+ charge. Nitrate ends in ATE. It's on the back of the periodic table. It's NO3 negative. And if we cross the charges, what I'm going to do is I'm going to bring the 2 down here and the 1 down here. So the 1 goes with the magnesium, doesn't impact anything. And the nitrate has a 2 down here. Can you tell me what I did wrong there? I need a bracket because I have 2 nitrates, not 32 oxygens. So we put a 2 plus charge, and then we have 2 negative 1 charges. And that's 2 negative to 2 positive, and that's it. End of the video. Answer a few more questions and let me know if you have any questions.